Save the applause for later. Okay, no, I'm just kidding. So yeah. I'll talk about serverless with Java today, and the easiest way to get a talk up somewhere is to put some buzzword in the title. And serverless has been around for a couple of years. I think it's 2012 it was first mentioned. So it's been around for a while, but still very few are using it, or some are using it a little bit, but it's still kind of a hot topic. My name is Ivar Grimstad. I work as a principal consultant at Cybercom. I'm also a Java champion and an Oracle developer champion. I'm involved in the Eclipse Foundation as the EE for J PMC Lead. I'm also in the Jakarta EE working group there. So if you want to talk about what's happening in the enterprise Java space, I'm probably a good guy to ask. I'm also in the executive committee in the Java community process, where Java EE used to be, where Java SE now is being held. And if you haven't noticed, tomorrow is the public review ballot for Java SE 12. So we're going on. Which Java versions are you on? Like 8? Yeah, most are on 8, yeah? So 12 is coming next year. So be prepared. I also run a Java forum here in Malmö, which we usually are hosting here. So most of you know me from there. So, serverless. I have prepared a couple of slides, not very much. I spend the most time preparing demos. And so I will demo quite a few different ways of writing serverless with Java, because Java is not the obvious choice for serverless. Mostly when you talk serverless, you write it in Node or Python or something else. So I'm focusing on Java, it's serverless with Java, and I'll show the different options available, or some of them. And the focus is on demos, so but I have a couple of slides first. Just go very quickly through some concepts, but I will get to the code soon. First of all, serverless is a very bad name. And why is it a bad name? Well, first of all, there are still servers. So you don't get rid of them. There are still servers. It's just that in this case, it's someone else's server, right? So you're not figuring out how to run your servers yourself. You're running on somebody else's. It's somebody else's problem. You just want to write your code and put it somewhere and let them take care of it. And do you know Kelsey Hightower? He's kind of the serverless guy from Google. He's a cloud guy from Google. He tweeted this in January. We asked 10 people to define serverless. We got 10,000 different answers. And if you find this tweet, it's just to search for him on Twitter and see the history. It's even more hilarious when people are starting to write about it. So there are a lot of opinions about it, and yeah, as you see, just Google it and you'll see. So what it really is then is running code without provisioning or managing the servers. It's somebody else's problem. But you can say that the same actually about an EC2 as well, to some extent, because Amazon is taking care of the stuff. You're just taking care of whatever you run on it. But serverless, we kind of move up in the stack a little bit. What it also is, and more important, is that it is a payment model. So it's actually just as interesting for business as it is for developers. Because in serverless paradigm, you pay for the time your function or your application runs. Whenever it doesn't do anything, you don't pay for it. If you set up a server somewhere and put an application and let it run there, and you get a request every now and then, you still pay for the entire time that application is running. But with serverless or functions, you pay only for the time they run. And how is this possible? Yeah, well, Amazon discovered that they had a lot of servers set up so they could handle the Black Friday. So they want to be able to handle the peak when everybody goes online and buys something. And every time in between, the servers are just idling there, so they sell out the capacity. That's how Amazon Web Services came about. And serverless is just taking it one step further. And so you only pay for the time you're using it. And serverless, as you see, it has 10,000 different definitions. It's also known as functions, or functions as a service, or cloud functions. That's kind of the same thing as serverless. If you claim that serverless is functions as a service, probably somebody will tell you that it's not, or somebody else will say yes it is. So there is a distinction a little bit there, but in this context, we'll talk about serverless as functions as a service, or cloud functions, as somebody tells it. And if you have this pyramid, you've probably seen it before, but if you start with the infrastructure, which is the networks and the machines, the stuff that you need to be able to run. This is and this is the kind of the basic cloud offering you get out there: infrastructure as a service, or IaaS. On top of that, you can have a platform as a service, or in this case, just a platform. And this is where you add a little bit more to it. And you can have containers as a service to run Kubernetes or Docker or something. And on top of all this, you run your applications. Right, so applications can be packaged in containers, or running using platform services, or running on bare metal infrastructure, or whatever you are in the stack. But you have your applications there. And functions as a service, or FaaS, serverless, comes in between the applications and the containers. There may be containers underneath, or there may not be containers underneath. That depends on how they do their stuff. Because the important thing with serverless is that whatever is below this line, you don't care about it. Because that's somebody else's job. Right? You write your functions and deploy it somewhere, and they could take care of all of this. So you don't care if it runs in Kubernetes or Docker or some other container mechanism. You just care about writing your code, get it somewhere, and run it, and somebody else can take care of it. So why do developers like it? I heard here that some developers didn't like it, but why should developers like it? First of all, it's easier. You only have to focus on this server. You don't have to think about how to manage them. You just write the function. It's very fast. You just write your small function and deploy it. So the iteration from writing your code to have it up and running is much faster. It's cheaper. Most developers don't care about that unless you pay for it yourself. So for development purposes, or if you're developing something at home, or doing stuff just for fun, it's good to have it cheap. But at work, we don't care about this. This is somebody else's pain. And it's super powerful. So because writing just a function and running it somewhere on somebody else's, whatever they have underneath, allows it to scale. Because a function doesn't have any state, or if you write state in a function, you're probably doing it wrong. But these functions can scale how much you want it to, and you can design for Black Friday or whatever you have for peak. So why does business like it? Well, it's very agile. You can have the development moving much faster with less dependencies, because you're just writing this function and it doesn't depend on anything other than whatever you have underneath, and you don't care about that. And it's easy to be innovative because devs can very fast iterate on new ideas and try it out, because you don't have to provision a server or buy some hardware or anything to get it up and running. You can just go there. And it's cheaper. You only pay for execution and not the idle time. So let's look at some, any questions so far? Yes?
If it's so cheap for you, how do you sell it to the client?
Well, business value. I mean, you don't sell server clock cycles or anything. It's
It's like you make a serverless product or a function.
yes.
Someone else has to run it.
Yeah.
I'm assuming there's some kind of business transaction between you and the person who has to run it on the server, right?
Okay, so I can go to Amazon and say, hey, I want to run this stuff on your infrastructure. This is my function. I just upload it and I pay for the time it runs.
Okay, so you're not selling to Amazon, you're selling this product to someone else.
To someone else, yeah.
Amazon's handling the server side.
Yes.
Gotcha.
Yes.
When you mentioned earlier that, yeah, you showed a picture, someone else
Yeah.
is responsible for that. Are we going to talk about the security issues as well, or?
My plan was not to go into that. I don't think there are any other security issues than you would have in any other cloud environment. The security mechanisms around it, whether you're on Amazon or Azure or whatever you're using, it's exactly the same for serverless as for any cloud. If you're talking on-premise security versus cloud security, that's a different question again. But and I think we can probably talk it over pizza. Serverless doesn't add any insecure or security issues there. It's the same. So let's look at some FaaS implementations or serverless. And the most well-known is AWS Lambda. And I'll distribute the slides afterwards. This is where you go and find information about Lambda. I will demo Lambda afterwards, and I will demo the Java part of it. As you see, you can write it in almost anything in Lambda. And Node.js, Python is probably the most used there. So I will demo Lambdas in a minute, but I think I'll just go through these first and then collect the demo at the end. Then we have Azure Functions from Microsoft. And they support C#, F#, JavaScript, Java, and more. And all of these are adding more as we speak. So that's why I put this list here, because it would be incomplete the minute I write the slides. So, and this one I'll also demo the Java version of it. Then we have Google Cloud Functions. They support Node.js. I think they probably are adding stuff, and this slide is a month or so old, or a couple of months old, so they may have added stuff. I was actually thinking if we had time to demo this as well, even though I would get dirty by touching the Node stuff. Then we have IBM Cloud Functions. They support, they run on the Apache OpenWhisk, which is an open source platform for serverless. And OpenWhisk supports JavaScript, Node, Swift, Python, Java, and more. So I'll demo the Java part here with OpenWhisk on IBM Cloud Functions. And as I said, OpenWhisk is an open source project. It's on Apache, so you can actually download this and run it locally if you want to. And if you are concerned about the security issues with moving to the cloud, then you can run serverless on-premise as well, and have the same security mechanisms as you would have in any on-premise solution. So OpenWhisk is an alternative to running on-premise. There's another open source project called FaaS, and this one you can also run on-premise. I will not demo this one. Then we have the FN project. And FN project is something that Oracle is investing heavily in. And they announced their contributions to this at Java 1 last year. And FM project, I'll demo that running locally. This is also something you can run on-premise, or you can run it in any cloud server instance. I was just before this talk setting up a Ubuntu instance in Oracle Cloud to see if I can run this there, but I don't think I have time for it. So I'll run this on locally on my machine. So, any questions more to the implementations? Had anybody heard about all these implementations? Or is serverless like AWS Lambda? You heard about all of them? Cool. Have you tried them? Yeah. Yeah. So I'll go in there to my IDE here. Let me see. Let me see which this is. This is AWS Lambda. So a typical function in Lambda would look like this. This is super simple. Your function would probably be a little longer and a little bit more complicated. But what this one does is it takes in a string or a JSON object of person. We can look at that afterwards. Just logs something to the Lambda logger, so you get it in the AWS logging system, and just returns a hello name to that person. So you see, it's super simple. This one is implementing the request handler of person to string, and that means the method takes in a person and returns a string. I could have returned an object here as well, or just omitted this one, and for string I don't need anything. I can just have an int in or something. So it's pretty simple to write that code.
Hey, question.
Yes.
That person, was that some kind of deserialization from JSON?
Yeah, the person object is. Let me go into it here. Oh, it won't. Let me see. See. The person object is just a dumb data object. It just has a name.
So essentially, the client can specify the
JSON. Yeah. I'll show how to invoke it.
The reason for my question is that it seems to be a very stateless method.
Yes.
There's no dependencies on a data source or.
No, and any function should be very stateless. You could depend on a data source without adding state. Anyway, so if this function should store this person, you would typically send it to a data store, or send it to an stream like Kafka or RabbitMQ or something.
Defer the statefulness somewhere else.
Yeah, the state would be in the data source and nowhere else. So the system shouldn't be.
Yeah, but I'm
The,
having a hard time understanding what are the actual implementations. I mean, there's a lot of trivial things. So
Yes.
This method, that's obviously this is nice to do in serverless, but
yeah.
anything more stateful than this?
Yes, if you have state in your application, you shouldn't go serverless.
No, but even data sources. I mean, where the client sends in all the
Yeah.
all the contexts and
Yes.
all the state, then it's just clock cycles in serverless.
Yeah. So in this case, if you were storing this one to a data source, you would typically do my data store store person, something like that. And you still wouldn't have state.
No, not in this case.
No. Or even better, you would have some kind of event system fire person created, and the other systems would take care of storing it.
Yeah, but why would you go serverless in that case? Because then you have the state in the.
Hmm.
I mean, this example kind of looks like a serverless engine.
Yes, this is an HTTP handler. I can show you other, but this one actually is not. The function doesn't say anything about how to trigger it. There are two things. So the function is just acting to some event. It will be clearer in 2 seconds when I show how to deploy it to Amazon, because I see the confusion. So this one is, let me go in there. This one is a standard Maven project. You can build it with any build system or just manually if you want to do that. This one is using the core lambdas. There are more stuff available there, but this is typically to get the logger and stuff, so to interact with the AWS systems. And it's using the shade plugin to create a jar file, which has both of these classes, dependencies in it. So I can build it very easily with just writing Maven package. And it will create a jar file for me. And all of these cloud providers do have some kind of client tool, but I didn't have time to install the AWS one, so I'll show how to do it in the browser. So in AWS, I've created a function here. I can show you how you can get started with it. So you go into AWS Lambda. You can search for a function and just create function. In this case, you can use some kind of pre-configured stuff, or you can just create it from scratch, choose which runtime you're using, and some kind of role and stuff. What I will do is to go in. That is what I have done here. So I want to have spend time for them to set it up. So typically I would set up just the name of the function and the security about which role are allowed to run the function and stuff. And in my case, I'm just uploading a zip file. So I go into where I built my Lambda function, and it's the shaded jar, and I just say it should be uploaded. I give it the name of the method, and if you remember from this one, the method is handle request, and it's in the package here and in this class. So I have to describe it somewhere that this is where it will be triggered. So whenever it triggers, this is the method. And if you do it in a command line or scripted, you probably have a JSON file or something. You just describe this and push it up. I can also set environments variable and other stuff and the security roles it should be running in, and etc. Just as you would do with any Amazon resource. And I just save it, and it's already ready to run. And now comes the thing you were talking about. If I want to test this one, I can test it with the built-in test. I can configure a test event here and say that, hey, I want to send in Duke, and see where it returns. So I just run test it, and somewhere here it should say hello Duke. And if I change the name it's sending in to something else, I would. So this is triggering with this test stuff. What I also can do here is to set up triggers, and I can set it up to be triggered through a API gateway or IoT or whatever I want to use for triggering. It could be a Alexa event. So I just said, Alexa, run hello Duke. So there are different triggers you can use. I can use Kafka or some IoT event coming from the other Amazon stuff. So it's very easy to set up and get running. And my function is just doing one thing. And if I get 100,000 events triggered by some kind of trigger, it coit could be HTTP, it could be an event queue, or it could be Kafka or Alexa or whatever. it will just run. And I also get all the logs out by just using the Lambda core APIs. So it's pretty pleasant. It's fast. It's easy to get up and running. And as I said, you can do this with the scripting as well. So we can go back to this after a while, but let's look at Azure. And in Microsoft Azure, it's very similar to how you do it at AWS. You typically go in and say, create a resource, search for function, and create it. And you have to set up some stuff, and it will just go on for a minute. So you set up how you want the pricing to be and where you want it to be running, and that's about it. I've prepared one for us. So I have, let me see. So I have this function Duke here, which I have created for us, and I have uploaded one function to it, which is called hello, in this case as well. So what I can do here, we can look at the code, how this one looks. As you see, as with the Amazon case, it's just a class with one method. And in this case, they are using annotations to saying which one it is. So it will be an annotation processor that goes through it and generates the stuff it's needed. If you're using a node or something else, it would use something else. In this case, it's you write in the function how you want it triggered. You can override it afterwards, but this is how if you want to default to something. So this is an HTTP triggered function. If I want this one, for example, to be not HTTP triggered, but I want it to run in some intervals. Let's see if I can find. Why don't I get suggestions there? Okay, let's go look at the triggers. So there are my ID has blown up. So there are other triggers you can code in, for example, a timer. So you want it to trigger with every interval or something. Or you can trigger it to some kind of Azure events. And in this case, you also have the execution context available, so you can get the loggers, you can log to the system. So your log files don't just disappear. The difference from this one to the Amazon is that this one is more tightly coupled to the triggering mechanism. So in this case, it is a request coming in. So in Amazon, is maybe more flexible, that you can trigger it by more mechanisms. In this case, you kind of say this is HTTP triggered or not. Let me see here. So in the Microsoft case, they've created a plugin for us. So you have as with the Amazon, you have some kind of core stuff that gives you useful things to deploy it, and you also have the Microsoft Azure Functions main plugin. So you give it the properties you need to be able to run it locally, deploy it, etc., etc. So it's pretty well documented in Microsoft. So I won't go through the details here, but it looks a bit verbose, but it's super simple to use. and it's, as I said, good, well documented. So the way this one is, it's Maven clean package as you would always do, and then you activate the Azure Functions plugin, and invoke the package code there as well. And this will package your function in a jar file that or a zip file or whatever you really don't need to care about how they do it. And then I can use the Maven plugin, or I can do it manually through the AWS Azure CLI system, or with the browser. But I'll use a Maven plugin here. So I can say to them Azure Functions deploy. And what this one will do is to push my function up to the Azure cloud. And if it's already there, just update the existing function. So this is super simple to execute from a Jenkins or a build server or whatever you have. And while this one is running, let's go in here and see at the existing one. So this is my function Duke at AzureWebsites.net. It's a bit slow, the network here. Yes, that is an issue, and that is a particular issue with Java, because in Java you also need to spin up the VM first. With Node, it's just there. So if you have something that you have really performance critical that you just want to run it faster, currently writing it in Python or Node is much faster, because a Java function needs to spin up the VM, and then they are optimizing so you can they kind of pre-spin it up, so it's running even though you're not paying for it. But at scale, Java today is much slower for functions than Node is. But that will hopefully be fixed in the future. So if you're like have extreme scale needs, then JavaScript is better. But that's the only time it's better. So here you can see the documentation, and this is what I was talking about here. In this case, I'm using the HTTP trigger to trigger it. You can use a timer. You can use GitHub. So whenever something is updated there, you trigger a function. Or you can come from the Cosmos DB, which is the Microsoft Azure stuff. Or when a file is uploaded, or something happens on a queue, an MQ or something, then you can trigger your functions. And they're good tutorials here, and pretty easy to get started. You only need a Azure account, and then you're good to go. Let me see if we can run this function as well. So this one, and I think it's API hello, isn't it? Let's see if I got it right. So the hello function here, which should be updated now. Okay, let's let this one just go in background, and I'll get back to it. The IBM function is also very similar to the others. In this case as well, you write a main method, more or less. This is Apache OpenWhisk, how they do it there. It's just, you just need a main method. And the main method need to have a JSON object as argument. So it's not the usual string array, it's a JSON object. That's the only difference from a usual Java main method. It doesn't have to be called main either, it just has to have a method with JSON object input. And here I can can get the name from the JSON input and return also a JSON object with a greeting saying hello, whatever name I got in. Oh yes, you can probably get it there. I just they didn't have it in their demo code. So the advantage of this way is that the POM file gets much simpler. So because here I can use the shade plugin to just generate a jar file. And the dependency I need is a JSON to get the JSON serialization done. And this one is just as simple to get started with, but it is I build it with Maven Clean package. That's nothing weird there. The next thing I need to do is to I'll remove the old one. So here I'm using Bluemix, which is IBM's cloud, and Whisk, which is OpenWhisk. So Bluemix has the Whisk CLI integrated. You can also integrate with Whisk directly if you have Whisk on your computer. So this is Apache Whisk way of doing it, but this is the Bluemix Whisk way. And in IBM, it looks like now I deleted it, so it should be gone. So I have here no functions. So if I go into the IDE here and write a Bluemix Whisk and action create hello Java, I just call it this. The target, the shaded jar, that's the jar file I built with Maven, and I say this is my main function, the function class, and I say web true, so it's triggered by a web trigger. Here I could use another trigger, or I can just configure it in the UI later. And I just run it here locally on my computer, and pretty soon it should be listed here as an action. Right, so I have the hello action function here, and then I can add triggers for different systems like the others. All is proprietary, so here we are in the IBM world of creating triggers. If I want to test this one, I can let me see. Hello Joe. Let's see if we can invoke it. Okay, there it says hello stranger. And hello stranger is because there is no input. So in the function it says if there are no name there, it will use stranger. So if I give it an input of a JSON here, let me see. Parameters, no. Let me see. Hello Java, there. Change input, and I say, hey, I want my name to be Duke. Apply this one. Come on. Sure, Duke. There. And then I invoke it, and it says, so you can test it here pretty easily. And then, of course, I can add triggers to it if I want to have it triggered by something else, for example, a mobile push or something coming through a message hub, which can be anything, or a timer, or GitHub even. Or I can do whatever. Yeah, this is their database, like Azure had Cosmos, they have Cloud. So it depends on the system and what triggers you're using. Some are HTTP and some something else. Let's see if the this one is up and running. Okay, I'm not sure if I have this. It's not expressing. So let me see. I'm not sure if I have this. Everything right here. So I see the pizza has come. So let's go very quickly the FN project. And FN project is something you can run locally and on a cloud. I'll demo it locally here. So this function is also super simple. I just need some method that in this case takes a string input and says hello to that string. So I can put in something else, like a JSON object or whatever I want. I just have to do pretty similar as what I did with the Lambda. I have to have an object that I can deserialize and serialize. But in this case, it's just string in, string out. The Maven POM for this one is has the stuff from FN projects you can interact with it, and also has testing for you, and it's just a compiler. And this one actually supports Java 9. So in this case, I'm actually running Java 9 on this one. The others are Java 8. So to run this one, I can do it manually, like doing Maven build and stuff, or I can use the FN CLI. And FN has a lot of stuff available for us to create this. So I can do a FN build. That will build my function. And see, it's pretty fast because I've built it already when I tested the demo. And what it has here is also a func YAML file, which is a descriptor file for my function. And this case, you can see it's 002 is my version. It's a Java runtime, and this is the method I'm invoking, and this is the JDK I'm using. So it's just basic information that the system needs to run this function. And the let me see. I can do FN call, and I think it's called FN Duke because I call it the same name. Okay, it's not. I haven't running it. I can say FN run, FN Duke. I think it's not that. Let me check my history. So FN run just. It will use the func file. So here it says hello world. So the function is running. It's running locally, and I'm just invoking it. So it's not that interesting. I can also send in a parameter because my hello function takes a parameter and uses that one if it's there. It writes world if it doesn't have an input, and it writes whatever it gets in if it has it. So if I echo Duke to FN run, it will write hello Duke. So this is how I can pass parameters to it. But this is just running locally, like when I'm testing. So this is not that interesting. What I also want to do is to run FN start. So and then I start the FN server, because it's serverless, so of course you have a server. The first thing you do when serverless is to start your server. Right? So and here it's somebody else's stuff, but it's mine. I'm doing it. But here you can run on premise if you want to and have it somewhere. So the FN is up and running, and I can invoke my function now using the FN call, FN Duke. And then /FN Duke, which is the path. And now it's running on my. Oh, I have to do FN deploy first, or FN start. I think it is. FN. Let me just see. Sorry about this. Yeah, I have to give it some. I have to create the app first. Let's see. Okay. There we go. Oh, I copied too much. FN, what was it? FN apps create. FN duck. It already exists, fine. And then I'll deploy it. And this is, let's see if I can copy it one more time. So FN deploy app, FN deploy app, FN duck, and then local. And here I could give it the IP address for my server or name of the server. And here we see it updates the image name to 003. It's still pretty fast because this one is based on Docker. So it just adds a new tag to the Docker image. And if I had done some changes, it would just replace the uppermost layer. Yeah, it is a Docker container running in the FN server. So the FN server should now have got the function in here. So I've deployed my Docker container with my function to the FN server. This is how this one works. And then I can FN call FN duck and the path duck. And it should say hello world. But this is still not very interesting because usually you would access it from somewhere else, for example HTTP or whatever. But in this case, it's on HTTP. So then I can, rather than doing FN call, I can actually do the HTTP call and do the HTTP to localhost on 8080, and then it's /r. That's just how it's configured default. FNDuck, name of the app, FNDuck is the path. And I don't think the Duke parameter will work. Of course, you can use a browser or a curl or anything, but HTTP is a pretty nice tool. And here you can see I do an HTTP request, I get a 200 and hello world back. And if this was deployed to a cloud, I would use something else on localhost. So this one was also pretty neat. It's very little code, and it's pretty easy to get running with it. That was what I had. You're hungry?
Was the idea first?
You can clap. Or we can take an